Hi and welcome to this course. Before we deep dive into the OSPF configurations, I think it's a good idea to first go through some OSPF basics. OSPF is a link state protocol that is based on shortest path first or Dijkstra algorithm. It is used to route packets within the same autonomous system. A loose definition of an autonomous system is that it's a set of devices under the same admin control and have the same routing policies. The way OSPF works is all the routers configured with OSPF flood link state advertisements to all other routers in the same autonomous system or in the same area if there are more than one areas configured in the OSPF domain. We will discuss OSPF areas in details in upcoming videos. Each router uses that information to calculate cost to each destination. That cost is also used to calculate routing table. So all the routers have same view of the topology. So look it this way, each router send the link state of its own links to all the routers in the same autonomous system or in the same area. All the receiving routers compile a topology table out of those link states that it received from other routers. And from that topology table, it drives a routing table that has got cost to each destination. So the topology table will be same for all routers because it's based on the same link state advertisements that it received from other routers. But the routing table can be different because the cost to a particular destination can be different for one router as compared to another router. Once we start OSPF configurations, I will go through the OSPF tables in details and I will show you what I mean when I say the topology table can be different from the routing table. We will go through the topology tables and we will go through the routing tables, and I will also show you how we can tweak the routing table while we keep the topology table same for all the routers in the same area. So I'll leave this discussion here and we will discuss it in detail in the upcoming videos. For now, what we need to understand is the topology table, the view of topology should be same for all the routers in the same autonomous system or in the same area if there are more than one areas configured in the same autonomous system. The default route preference of OSPF in Junos is 10 for internal routes and 150 for external routes. Route preference is similar to the concept of administrative distance in Cisco terminology. In Cisco, both internal and external routes have admin distance of 110, as you know. The admin distance is used to select the route to a destination if there are more than one routes available from more than one protocols. So OSPF routes get a preference of 10 in Junos for internal routes and 150 for the external routes. External routes are the routes that are advertised through OSPF, but they were originally learned from some other protocol, like from static route or from connected or from BGP. OSPF currently have two versions, OSPF version 2 for IPv4 and OSPF version 3 for IPv6. OSPF supports simple as well as MD5 authentication on Juniper routers. And as I mentioned earlier, OSPF can have more than one areas, but all the areas need to be connected to the backbone area, that is area 0. We can have only one area. In that case, that area number does not matter, whichever number you choose. But if you want to have more than one areas, they will have to be connected to an area 0, which is a backbone area. The routers that sit between the backbone area and the other areas are called area border routers or ABRs. We'll go into areas details and we will configure different types of areas in the upcoming videos. OSPF header contains information about version number. It can be 2 or 3, that is the OSPF version as we discussed earlier. OSPF version 2 means IPv4 OSPF and version 3 means IPv6 OSPF. It contains the type of the OSPF packet. An OSPF packet can be a hello packet. Hello packets are used to discover and maintain neighbors. Once you configure OSPF on a router, is start sending hello packets to discover other neighbors. Hello packets are multicasted or unicasted. They are multicasted in the case of physical networks that support multicast or broadcast, like Ethernet, and they are unicasted where the physical network does not support sending of multicast packets, like frame relay networks. Another OSPF packet type is database description packets. These are used to check database synchronization between the routers. A link state request packet. These are used to request specific link state records. Then there is link state update packet. These are sent in response to the link state request packet. Link state acknowledgement packets are used between the routers when they are exchanging LSAs to make sure the LSA request is received and LSA update is received in response of an LSA request. So when a router starts and neighbor is in the process of coming up, router exchange the databases with the new router, and that database description packet has got information about all the links that the router knows about. The receiving router look at the DBD packet, then it decide which links it need more information about. Then it creates a link state request packet which has the request for the links it does not have enough information for. In response to the link state request packet, it receives a link state update that has got all the information about the links that it requested. Then in OSPF header, there is a length of packet in bytes, including the header. That is the packet length of the OSPF packet itself. Then the header has an area ID. As I said, OSPF can be divided into multiple areas. The concept is, within the same area, all the routers will send link state advertisements and they will create topology tables based on those link state, and that topology table will be same within the same area. If the number of routers is massive in the same area, then maintaining that requirement becomes problematic. So that's why OSPF supports division of your autonomous system into multiple areas. Once we start configuring multiple areas and we connect areas together and we do filtering or summarization between those areas, then these things will become more clearer to you. For now, what we need to understand is OSPF domain can be divided into different areas, and each area will have an area ID. An area ID is a 4-byte number. OSPF supports simple as well as MD5 authentication. We will do OSPF authentication in this course as well. That's it for the OSPF introduction. In the next video, we will start configuring OSPF. While we configure the OSPF, we will carry on the discussion of different OSPF concepts. So that's it for now. See you in the next video.